Hi, welcome to section 8.6, radical equations. There will be no book homework for section 8.5 and no lecture video. I'm going to get rid of the book assignment. You'll just have one thing of Newton to go over, but that's about it. Okay, so 8.6, solving radical equations, the end of this section, we're going to solve radical equations with one or two radicals, and that's about it. I don't think we're going to do any applications today. So what is a radical equation? It's basically an equation that has a radical inside of it, like, something like this. So how do we solve an equation that has one radical? You basically isolate the radical by itself and then raise both sides of the equation to the power of whatever the index number is, solve the new equation, and check the answer. So let's do that. So we have here, we're isolating the radical. You get square root of 5n minus 4. That's equal to 9. We square both sides because this is a square root. Remember, when it's nothing, there's a little 2 there. That cancel this here. You get 5n minus 4 is equal to 81. Add 4, we get 5n, going up here. 5n is equal to 85, divide by 5. And you get that n is equal to 17. Now, if you plug that back in, you'll see that it's correct. Let's go ahead and do another one. So let's see here. We want to get this radical by itself, but here we have square root of 9k minus 2 is equal to negative 1. Remember, the square root function, it's positive, right? So this here has no solution. Okay? Because we don't have square root function is a positive number. The output of a square root is positive, unless it's we're going to talk about i's, but for an even root that doesn't work. So okay, one thing that would help you to do these types of problems is remember binomial squares. So let's say here we're isolating square root of p minus 1 is equal to p minus 1. And then how do we isolate the radical? So square root both sides. On the left-hand side, you get p minus 1. On the right-hand side, it's a perfect square trinomial, p squared minus 2p plus 1. Solve this for 0. You get 0 equal to p squared minus 3p plus 2. This factors in 2. P minus 1, p minus 2. So your final answer, p is equal to 1 or 2. Okay, so that's it. And they're both correct. All right, let's solve another one. We have here cube root of, this is now a different radical, right? It's not squaring anymore. So let's go ahead and solve this. Minus 8. We have cube root of 5x plus 1 is equal to negative 4. Let's take the cube of both sides. We get 5x plus 1 is equal to negative 64. So minus 1, 5x is equal to negative 65. Divide by 5. X is equal to negative 13. And that's fine because it's a cube root. We don't have to, worry about that. Okay, now fourth root. So again, isolate the radical, or the, rational exponent. So this is like saying fourth root of 3x minus 2 is equal to 2. Take both sides to the fourth power, raise it to the fourth power. We get 3x minus 2 on the left. To the fourth power is 16. 16, why did I write 6? Okay, here, 16. I don't know, I'm getting ahead of myself. Okay, here, and then let's solve for x. Plus 2 plus 2. 3x is equal to 18. Divide by 3. We get x is equal to 6. Okay, let's do another one. Square root of r plus 4 minus r plus 2 is equal to 0. So we're going to isolate the radical by moving everything else to the other side. So then that's going to get, using, of course, the addition property and subtraction property of algebra, right? The algebraic property. So r minus 2 is on the right-hand side. On the left-hand side is the radical. Square both sides. You get r plus 4 is equal to r squared minus 4r plus 4, right? I used the, perfect square. So subtract 4 from both sides. Subtract r from both sides. We get 0 is equal to r squared minus 5r, and that's it. Factor r minus 5. Your two answers are, get it? R equals 0, and r, oh no, what happened? What just happened? Come on. R equals 0 and r is equal to 5. Sorry about that, people. R is equal to 5. Why aren't you working? What is happening right now? Wait a second. Sorry. Chapter 8. Okay, this should be where we were. Sometimes I think my iPad has a mind of its own. Just kind of does whatever it wants to do. Okay, so r is equal to 5. Okay. Next, we have one with the coefficient in front. So that's interesting. So plus 8, we're isolating. We have 3 square root of 3x minus 5 is equal to 12. Divide by 3, because we want to get the square root by itself. 3x minus 5 is equal to 4. Square both sides. We get 3x minus 5 is equal to 16. Add 5. 3x is equal to 21. Divide by 3, and we get x is equal to 7. Okay, what about something like this? This looks crazy, but the both sides have cube root, so we can just take the cube of both sides. And what happens is they cancel out. So you get 4x minus 3, and then you just have a simple algebraic equation. So subtract 3x from both sides. We get x minus 3 is equal to 2, plus 3, and x is equal to 5. Okay, so just to recap, what if you have more than one radical? Isolate one of the radical terms on one side, raise both sides to the power of the index. If there's any more, just repeat. So let's show you this. Here, m plus 9 is already isolated, so what I'm going to do is I'm going to square both sides. That's going to get rid of that m plus 9 root on the right. But on the left, this is a case of, this is a binomial squared, right? So it's going to be square root of m squared plus 2 times 1 times square root of m plus 1 squared, which is just 1. So this is going to become m plus 2 root m plus 1 is equal to m plus 9. So minus m minus 1 minus 1. We're going to get 2 square root of m is equal to 8. Okay, and then that, we're going to divide both sides by 2. We get square root of m is equal to 4. So squaring, we get squaring m is equal to 16. Okay. So let's do one more of that. Here, we're going to square both sides. Okay, so the right-hand side is just going to become 4q plus 1. The left-hand side, this is a and this is b. So square root of q minus 2 squared plus 2 times 3 times square root of q minus 2 plus 9, right? 3 squared. So this just becomes q minus 2 plus 6 root q minus 2 plus 9 is equal to 4q plus 1. Okay, 7. So this is going to be, this is a q. So negative 2 plus 9 is 7. So let's subtract this q from both sides, move this over. This 2 and this 9 is 7, so minus 7 minus 7. So we get 6 square root of q minus 2 is equal to 3q minus 6, divide by 6, okay? Okay, and then you get square root of q minus 2 is equal to, I'm dividing everything by 3 just to simplify it, q minus 2 all over 2. Square both sides, square both sides. We get, this is a little bit longer here, I'll get this other pen here. So q minus 2 on the left is equal to q minus 2 squared over 4. So then q minus 2 is equal to, let's see, q squared minus 2 times 2q, so that's 4q. I'm running out of space, so I'm just going to use the properties, and I'm going to say them out loud. Plus 4 divided by 4. So then plus 2 minus q plus 2 minus q. Okay, so that's going to be 0 is equal to 1/4. I'm applying the 4 to everything. Q squared minus q plus 1 plus 2 minus q. Combining like terms, 0 is equal to 1/4 q squared minus 2q plus 3. This is a fraction, so let's multiply everything by 4. 0 equals q squared minus 8q plus 12. Right? I don't know what I'm doing here. 12. Okay, yeah. I don't know why I've been saying things and then I write what the next step is, and that's unfortunate because I'm a little ahead of myself here. Okay, so then that, what did I do? I multiplied both sides by 4, by the way. So 4 times 0 is 0, and then 4 times everything on the right becomes this. So this simplifies to q minus 0, q minus 6, and q minus 2. You can check me. Yeah, so then q is going to equal 6 and positive 2. And that's it. Okay, that's it for section 8.6. Good luck. Here's your homework. Enjoy, and I will see you in the next video.